Um, I want to show you something. It's a unique item, or at least I consider it a unique item. It's a test transmitter. Yeah, I know I have a lot of transmitters on my channel, but RF stuff can be really interesting. And this is not about the transmitter being special or anything. It's more about it being really old and really rare. This is what I want to show you later. And it says KB Electronic, the biggest program for the hobby enthusiasts, electronics enthusiasts, medium wave test transmitter. This small medium wave test transmitter is a universal helper. It all works on AM radios or medium wave radios. And this is how or where it came in. This is a small box. You have a ferrite staff, wire, then you can't see it, but here is another bag, like this, like the outer bag that contained resistors, capacitors, all the parts you need to use it. And there was the main circuit board inside this box. If I turn it around, it just gives you some advertising and also someone glued a price on it, 18 Deutschmarks, about $9. In many decades ago, it cost that much. Probably if you had it today, it would cost more, or it would cost a lot less because it's made in China and costs nothing but provides a lots of parts and things. I mean, you know how cheap the things from China are, but often you get quite good circuits from them. Anyhow, this is advertising. Examples from KB Electronic Kit Program, FM test transmitter. Everyone has to have this one. If I mean, I know a lot of people who started with electronics, and basically nearly everyone got this test transmitter. Light barrier, power controller, anti-distortion preamplifier. This is what you use in a record player. Universal preamplifier, integrated circuit, audio amplifier, 5 to 20 watt. I don't want to read everything because it would take too much time. For hobby enthusiasts, schools, and workshops. This is what it says down here under the price tag. And there's more text, but I don't want to read it because, like I said, time is really short in these 15-minute videos. Okay, I have this circuit here, and this is a copycat thing from this one. So there's this website, Yogis Röhrenbude, and there is the original one. You can search for Yogis Röhrenbude. On Yogis Röhrenbude, you find the original KB Electronic AM test transmitter. It's a blue circuit board with a coil. This is basically the same coil, one transistor, some components. And I had the original one. And some 10 years ago, the original one was very well available on a well-known auction house. On the auction house, I also got the other transmitter. And I want to demonstrate you something about these transmitters. So the transmitter is already on, and what I have here is a very expensive and very fancy communications receiver. I bought it new. It was very expensive, but like I said, it's expensive and worth every cent. Anyhow, I connect up my cassette player. Here's my cassette player. And I connect it. And as you can see, there is this arrow, AFC, this one. And it shows this direction. It tells me the frequency is deeper, deeper, deeper. There it is. No more arrow. If I go below the frequency, it tells frequency up. I have a lot of communications receiver, but only this one has this function, and it's very helpful. Anyhow, I've connected my audio source, and now I push play. And the first thing that you notice is the signal is gone. Now let's search the signal. Where is it? Just me pushing play already changes. I push stop, pushing rewind, pushing any control on my cassette player will change the frequency. And I can already tell you why. This is the schematic, not of this transmitter. This is very similar, but this is the original one, and the original one performed similar. Colpitts oscillator, here's the capacitor missing. Here is from minus to plus capacitor missing. And this one, you would need a capacitor from here to ground to protect it from making what it makes. There's another thing what I want to show you. I know this is a bit off topic, but I want to get into this. Pushing play, and I have a regular radio here, like the one you can buy in thrift store. It's just your typical cheapo radio, but it does work. And it has a dodgy contact because it uses the big D cells, and I have AA cells in it. Don't ask how I got them in there, but I got them in there. Anyhow, so I'm going to push play. There's some volume here. Let's reduce the volume. So, okay, it went off again. Here, you hear it. Now let's tune it exactly on the frequency. Listen. Not the frequency. Frequency. I'm not sure if you can pick it up through the microphone, but as soon as you tune it exactly on the frequency, it is getting very silent, it is getting very distorted. And this is what these simple transmitters do have, because they have one transistor, and as soon as you change the current in the emitter, you will get a frequency change. Not forced. I built a transmitter too. It uses a vintage transistor, VC147. Some of them were broken out of the package because they are that old that moisture got into them, causing them to be destroyed. Like they had a connection from collector to emitter, although base was not connected. This one works though. I built a one transistor AM transmitter, and this one does make good AM. If it was on 1.171, you could tune the radio spot on to the frequency and it would have a good audio quality. This coil has two coils. One coil is the oscillator coil and the other coil just picks up the signal and offers it on these pins so you can connect your receiver here. So I can build a one transistor AM transmitter that does make good AM. Why can't the company? Okay, it took me more than 1 year to figure out how to build it. I have to admit that too. Anyhow, how much time do I have left? Let me check. Okay, about half time through the video. Okay, now let's look at this transmitter. I hope I get to show you some things. Yeah, okay, so here's the paper, and it's just printed on one side. So on the back side there is nothing, it's empty. And I notice, look how they wrote transistor. Like someone hand wrote that. Someone made a hand drawing, and it's transistor. Let's write that down. Okay, so here it just says caution, pay attention to the poster regulations like FCC regulations, because unlike America, where you can broadcast with up to 100 milliwatt on AM, Germany is very restricted, and most European countries are very restricted about broadcasting. There is a thing that you can use these transmitters that relates to inductive transmission. Like the coil is making a magnetic field, it's also making an electric field, but you can use them, but you have to really pay attention. You really have to pay attention what you are doing. Oh my, this is the third or fourth recording, and starting to lack in concentration when it comes to talking English. Anyhow, here's the schematic. And first you notice it's a Meissner oscillator because you have two coils. One coil feeds in the other coil to generate the phase shift. And this audio amplifier with two transistors is very, I mean, what are they doing here? Everything is DC coupled here. The bias from the oscillator comes from the audio amplifier. Somehow it's DC coupled there. And another thing I noticed is that if you look at the schematic, here's ein input, you have your capacitor and you have ground. But if you look at the ein here, you will see one goes to the capacitor here, and the other one does not go to ground. Instead it goes here to base. Okay, well, this is sort of a matching up. I referred that to ground. It's correct. I'm sorry, I made a mistake. Anyhow, so it says, this small AM test transmitter is a universal helper with all works on medium wave radios. With its built-in modulation amplifier, you can connect a source like a microphone or another signal source like a record player, a cassette player. It doesn't say cassette player. It's more this huge reel type of cassette players. You can connect them directly to the circuit, hence the fancy audio amplifier. Caution. You're not allowed to use this transmitter as a spy bug or to eavesdrop on people, like you put a microphone on it and hide it in a room and you can listen to the conversations via the radio. This is forbidden in the German Republic, especially in West Berlin. Put the finished device into a metal housing and do not use it along with a very long antenna. Otherwise, you may get a range of a few hundred meters transmission range. Okay, I wonder what they call a very long antenna. Building the thing is uncritical. Building the device is uncritical. The device is easy to build. Just pay attention to wind the coil correct and connect the coil correctly to the circuit board. They give you an explanation how to connect the coil, because if you have the polarity inverted from the coil, it will not transmit a signal. Watch the maximum power supply voltage is 6 volts. We recommend 4.5 volts. As antenna, use a long wire. As ground, use a water pipe or the central heater pipe. And then it just talks about how to set it up. They tell you to connect everything after the circuit board has been put together. Sorry for skipping so much, but time is running out on the video. They tell you to check your soldering and then connect it up, tune the radio to 1.1 megahertz, and then you have to adjust the coil with this tuning slug, or not tuning slug, Farad staff. You have to wind the coil so the Farad staff can be moved in and out into the coil, so like this. And by sliding the Farad staff, you adjust the frequency. And once you have adjusted it, you have to tape it down to keep the frequency. This is basically what they are saying in the manual, and this is pretty much everything they say. Okay, let's demonstrate it now. And yeah, let's demonstrate the thing. I have batteries, 4.5 volts. Oh, time is running out. This is so annoying, this 15 minutes limit. I mean, I'm so long at YouTube. Can't it just be like, okay, he's old on YouTube, he's not a newbie, we allow him to make longer videos. But no, without my mobile number, 15 minutes is the limit. You wouldn't believe it until 2024, but here they go. Okay. There I have a signal. As you can see on the bars moving. And now if I crank up the volume and press play, it's working.
Danke, mir geht es gut. Klosterfrau, wir helfen Ihnen. Ich stehe auf Schokolade, die was Spezielles hat.
Gut, dass es Thermoscherie
FM. AM? Distorted, silent and distorted. FM?
Und leicht vorgekühlt.
Good to hear. Okay, so this transmitter does work, but just like the other transmitter, it does produce extremely much FM. I checked it on the scope. The signal is going in this direction, but not in this direction. So we have a lot of FM. I would love to show you a lot more about this transmitter. Oh, we still have 2 minutes. Cool. But yeah. Okay, we still have 2 minutes. I thought it's much later. Anyhow, when building the transmitter, I ran out of wire. They give you a lot of wire to wind the coil, the 75 turns and the 85 turns. I wound the 75 turns and most of the wire was just in the coil. So I had to use my personal, quote-unquote, personal wire to continue winding the coil. I do have this copper wire myself. The one I use is a bit thicker than the one that is there, but the one they supply you with definitely is not enough for making all the turns for the coil. Since this amplifier is DC biased, everything is connected DC-wise. Depending how much voltage you add to the transmitter, it will give you a good modulation or not so good modulation. I also have the scope picture here somewhere. I can't find it now. I did scope this thing, and it makes the sine wave looks like this. It goes up, and usually it should be this bow. But it goes up, then it has a hill, goes down, and goes up again. It looks quite odd on the scope. And it goes up 2 volts, it goes up, and 1 volt it goes down. It goes down like this, and then it is straight, and then it goes like this, like cut off, like square wave. And it doesn't matter what voltage you use. I tried different voltages. You can't get the signal to look like you want it to look on the oscilloscope. But yeah, it's working. I mean, it's doing its thing. I can manage to get it transmit into a radio. Yeah, I mean, it does work, but why can't they make it with good AM? With good AM, good amplitude modulation. Yeah, but this was a very rare and very vintage kit. I hope you enjoyed the video. Thank you for watching. Best regards, Stefan.